3.4 Operations on Functions. We are going to learn how to add, subtract, multiply, and divide two functions, specifying the domain, how to evaluate composite functions, determine the domain for composite functions. So when two functions add, we will have the f of x plus g of x. So you will see the notation like f plus g is defined by f plus g with the input variable is x. So this is the same meaning you use f of x plus g of x. Same way to apply with the differences, which means two functions you subtract, you will have the minus sign in between of the two functions. Product of the f and g, so you will see a dot f dot g at a point of x. This is the equivalent f of x multiplied with g of x. The quotient of f and g, you will see the f divided by g of the point x. This is equal f of x divided by g of x. Your g of x cannot be equal to 0 because your function will turn to undefined. So we do a practice. Let f of x is this function, g is a square root x function. Find each function and its domain. So a is a plus g. So when you have f function plus g function, so this will be f of x plus g of x. So f of x has x squared minus 4. G of x has square root x. If you look at this 3, you cannot combine like term. So you just leave it like that. That would be the answer. Now, the challenging part is giving the domain when you combine these two functions. So let me sketch the graph of this one. X squared minus 4 is a parabola facing up. Okay, so this is x squared minus 4. Now square root x is a radical function. So it has a 90. It has 90 curve start from the 0, 0 or toward to the infinity. So this is the square root x. Now, since these two functions combine already, so the whole output will be here. So when you determine the domain, we are looking for the overlap region they have. So the overlap region will be from here until forever, right? So as here you can see the most left-hand side on the domain to satisfy both of the function f of x and g of x, that would be starting point is here. Because if you look at the -1, the square root x doesn't cover the -1. So the square root x is start from 0, 0. So we have to represent the domain when a new composed function is start from 0. And 0 is a bracket, right? So we'll have the domain of the part A would be bracket 0, go to infinity. That would be the domain of your part A. F dot g. So when you have f multiplied with g, it has x squared minus 4 multiply square root x. So when I distribute it, I get an x squared root x minus 4 root x. Determine the domain of this one. Again, we are looking for the region they are overlapping. So x squared multiplied with x. Let me draw the graph. When you have the x squared parabola multiply with the square root x, so it's here, then minus 4 root x. So minus 4 root x is another part of the 90 curve. So now we just need to look at the graph and see which region they are overlapped. So as here you can see, the region they are overlapped is start from 0, 0 and go to forever. So the domain of your part B is the same like the part A, is a bracket 0, comma, infinity. That will be the domain. F divided by G, so we will have x squared minus 4 divided by root x. Now, according to the definition, when you have the two function divide, you have to make sure your g of x cannot equal 0. If you look at the denominator part here, we have the root x, and we cannot take the 0, right? So the square root x cannot be equal to 0. So that means the square root, the radical function we have here, our beginning point is no longer bracket 0. We have to change it to open 0. Open 0 and go to forever. The numerator here, again, has the quadratic function. It go down 4. So the part, they are overlapped. The region they are overlapped to satisfy when two functions divide would be, again, from 0 here until forever. Now, just because the square root x is on the bottom, so we cannot cover the point 0 anymore. So we have to change the bracket into the open parenthesis. So the domain of the part C would be open 0, go to infinity. G divided by F. So the G function is a root x. F function has a square root x. Sorry. F function has x squared minus 4. So now, the denominator part here, finding the restriction point, that's the same idea, right? So we set the bottom part equals 0. That means x cannot equal 2 or negative 2. These 2 points we have to avoid in order to make the function continuous. And the numerator has x. So numerator again is start from bracket 0, go to infinity, right? But we cannot have the 2 occur within the graph, within the domain region. So we have to avoid this point 2. Negative 2, it doesn't matter because negative 2 is here. And your square root function, it will not go touch the negative 2. So I'm not going to worry about this number. So the domain of this function would be from here, from bracket 0, go to infinity. But when the graph come to 2, you have to leave that open. So put a union 2 to the infinity. Let me write down here one more time. So the domain for the part D will be bracket 0, comma 2, open, union, another open parenthesis, 2 to the infinity. So when you determine the domain, you need to consider when two functions combine, the region you are looking at, that would be the part they are overlap. So you have to consider what would be the most left-hand side point, especially when you have the square root x function.